Good morning. I am Kavita, working as assistant professor in the Department of Computer Science and Engineering in Sri Muthukumaran Institute of Technology. Today I am going to present a topic in Introduction to Operating System. The subject code is CS3451. This is Unit 2. It contains process concept, process scheduling, operations on process, inter-process communication, example of inter-process communication systems, communication in client-server system. First, objective. Objective is after learning this unit, the student will understand what is a process, how a process runs inside the computer, how CPU switches between process, and what are threads, how process communicate with each other. For example, just like learning traffic rules before driving. This unit teaches how programs run inside a computer. Process concept. An operating system execute a variety of programs. A process is a program in execution. In simple word, we can say that program it is a recipe, and a process is a cooking the recipe. So it is nothing but recipe is a program and process is a cooking the recipe. A real-time example, the real-time for this processes program WhatsApp application installed in your pro app, and then process, which is nothing but the application that is WhatsApp running when you open it. If you open Chrome or Chrome, YouTube, WhatsApp, each one is a separate process. Process and memory. Here, it is nothing but when a process run, it occupies memory parts like program counter, data, stack, and heap. So stack, which is nothing but function call, and heap, which is nothing but it is a dynamic memory. Think of a student in a classroom. Notebook is a code. Notebook is a code. School bag is a data, and a disk is a stack, and extra books are the heap. Then process state. A process state, which is nothing but a process changes its state while executing. It has five states. One is new, running, waiting, ready, and terminated. New, which is nothing but process is created. Ready is waiting for CPU. uh, Running is CPU is executing it. Waiting is waiting for input output devices. Terminated is after completing the process, that means process finished. So the real-time example is booking ticket is a new process. It is a new, and waiting in a queue is ready, and at counter the queue is running, and a payment delay is a waiting, ticket receive is a terminated. This is a process state diagram. The diagram shows movement between states. So CPU decide who runs, who waits, who finishes. So simply we can say it like a traffic signal controlling the vehicle movement. So the CPU have to decide which one is going to start, which one have to wait, and which is finish the process and terminate it. And then process control block. What is process control block? It is nothing but a data structure that stores all information about your process. It contains process ID, process state, process program counter, process number, register, CPU register, memory information. So it is nothing but program counter block, which is like a student ID card. So the student ID card contains name, roll number, class, attendance, etc. So that is called as process control block. And then CPU switches from process to process. Here, here which is nothing but the teacher teach. max for 5 minutes, then go to science, then English. So likewise, students feel all subjects are tough together. So CPU can execute only one process at a time. So it switches quickly between process. This switching is very fast. It's like milliseconds. And then thread is, which is nothing but it is a smallest unit inside your process. So one tab downloading, one tab playing video, and one tab loading page in a browser. So all inside one browser. So that is the process. So process scheduling, which is nothing but process scheduling decide which process gets CPU first. For example, in a hospital, doctor decide emergency patient first and others wait. So similarly, operating system decide which process run, which should take wait, which should take terminate. So here operating system only have to decide the states. And in scheduler we have a long-term scheduler, short-term scheduler. So in long-term scheduler it selects the job from disk to memory. For example, admission process in college, that is a long-term process. Shortest term process, which is nothing but it selects a process for CPU. For example, teacher selecting student to answer, that is a shortest term scheduler. And then medium term scheduler, which is nothing but suspend and resumes process. For example, students in outside and call back. And then multitasking in mobile system, mobile phones run multiple applications at the same time. So for example, the multiple task in the mobile, we can use music, we can play music and using WhatsApp chatting, also browser downloading. So the multiple task in a single mobile phone. So mobile phones runs multiple application at the same time, that is called multiple tasking in mobile applications. CPU switches between application very fast. That's why phone feels smooth. And in context switching, which is nothing but saving one process state and loading another process state. So when CPU switches to another process, the system must save the state of the old process and load the saved state for the new process by using the context switch. For example, we can steady max in a phone call and continue the subject. You remember where you stopped. That memory saving is context switching. Operation and process can say a process can create, execute, wait and terminate. That is a operation and process creation. A process creation can create child process. A parent process create child process, when it turns create other process, forming a tree of process. For example, browser opens, a new tab opens. A new tab is called as child process. Process termination. A process ends when task is completed, error occurs, user close application. So this is process termination. For example, closing YouTube application, that is a process terminated. And in inter-process communication, process communicate with each other. Process within a system may be independent or cooperating. Cooperating process can affect or be affected by the other process, including sharing data. For example, browser sends file to printer, music application sends sound to a speaker. That is a real-time example for inter-process communication. Communication models here have two models, shared memory and a message passing. For example, shared notebook is example for shared memory. and WhatsApp message is a message passing. Cooperating process, that which is nothing but it is a work together or called cooperating process. It can be independent or cooperating. An independent process cannot affect or be affected by the executions of another process, and in cooperating process it can affect and affected by the executions of another process. The advantages of process cooperation is information sharing, computation speed up, and modularity and convenience. The real-time example is we are using a camera in a gallery and a Google map in a GPS. That is a cooperating process. And producer consumer problem. What is producer consumer problem? It is a one process produce data, another consumes data. That is a producer consumer problem. For example, if a chef cooks food, waiter serves food. So this is a real-time example for the producer-consumer problem.